Okay, today we will hopefully complete our discussions on induction motors. Okay. We have seen how the induction motors can be used and abused till now on 3-phase motors, single phase motors, 2-phase motors, multi-phase motors, wound rotor motors, squirrel cage motors, and 3-phase motor with single phase supply, single phase motor with single phase supplies. So, we have done all permutations and combinations. So, that means it is a special operation of induction motors which has been discussed. Today we would like to discuss an important aspect of this, that is testing of such small motors. See, often there is more problem in testing small motors than testing large motors. Maybe a pediatrician has a more problem than dealing or treating adults, right. And similarly, the small motors have their own problems. And there is always certain comparison between a doctor and an engineer. A car mechanic, he does also fixes the car, and a doctor also fixes the human beings, right. He does all the opens your heart and puts back and things like that. So, but the doctor once, when they told what is the difference between a mechanic, car mechanic and a doctor, and but the doctor told, okay, ask your car mechanic to repair the car when the engine is running. That was the doctor told, because doctor will have to, he cannot stop your everything, you can't be. So, that is the difference, right. Same thing, in small motors also there are some special problems of testing. So, we will discuss this, because since the whole subject we are discussing is special electrical machines, and bulk of them are the small ones. As we said, an automobile will have about 25 to 30 motors, right. They are all small. Now, what are the problems of these small motors? And why do we need to do the testing? Because first of all, after a motor is made in a factory, why do you want to test? You want to test it because you want to find out its parameters. You know it, how it is modeled through the equivalent circuit approach, but how do you find those circuit parameters? That is one of the important objective of conducting some tests, right. Then you should you know what is, you should have the characteristics of these motors, you should determine how will it behave, and very critical. And then how much you can load the motor, what factor, what limits in loading the motor, a given motor, how far you will be loading. Now, why are we interested in how much I load a motor? Is it so critical? Why is it critical? So, it tells you about the capacity of the motor. When you say a 1 kilowatt motor, why do you say it is a 1 kilowatt motor? Why do I call it as a 1 kilowatt motor? You can continuously take out 1 kilowatt out of it, right. If I continuously take out 2 kilowatt out of it, what happens? So, you overheat it. So, as a person, he is supposed to carry certain load on his head. If you put more load on his head, he will collapse, or he will fall sick, or break his bones, or whatever it is, right. So, something happens to the motor. So, it will just increase, if you increase the loading, it will overheat. Currents, there is a capacity of the windings to carry current, and also there may be magnetic field distortions and various things. There will be more losses also. So, all these things do matter. Okay. So, you would like to know all these things by actually conducting the testing. You have designed a motor at the design table, okay. And then you also analyze the motor, you have manufactured the motor as per your designs. Okay. So, it looks nice, right, but unless you prove, okay, then you know that it is good, then it is no use, right. It is always, it is called worth of the pudding is in the eating. You have the recipe book, you take the raw materials, okay, prepare this thing, and but if nobody can eat it, right. So, your testing is like eating, right. That means how much you can whatever preparations are made is palatable, okay, for the purpose for it is made, right. Therefore, I think the testing is therefore very critical. Okay. Okay. Then you have the measuring devices, okay. You measure something, okay, right, just like everybody measures the blood pressure, sugar, height and various things as human beings. So, you measure the for the motor. So, in motor you do not so much bother about measuring its physical parameters, right, because it is an electromagnetic or electromechanical device. So, you are more interested in measuring electromechanical parameters. Okay. So, the devices that you use to measure, okay, should be able to measure which are, because the quantities are very small. See, you are talking of milliamperes, you are talking of small torques, okay, and you are often talking of very high speeds. Okay. As it is said, you know, for example, the drill machine of a dentist drill machine speed around 60,000 rpm. Okay. So, you do not realize when your teeth is being extracted, but that is the speed to which the motor is running, okay, drill machine. Okay. Now, same thing, you know, any normal drilling also very large mixes. So, high speeds, and then whatever, you know, when you connect these meters, okay, then it should not itself start consuming power, right. If you connect an ammeter, it will consume power, connect a voltmeter, it will consume power, connect a wattmeter, consume power, connect a speedometer, it consumes power, is not it? They all consume power. So, a measurement is always effects in providing impurity to the system. Any measurement means you are distorting the system. Whenever you put an instrument, means you are loading the system. Okay. So, this is the basic thing of a measurement, right. Now, that loading of the system must be minimized, is it clear? Okay. So, then that means it should not it should consume less power. This is one of the factors of measurement. Okay. And you know, temperature of the machine should be controlled while testing. See, parameters are sensitive to temperatures, and the temperatures are machine temperatures will considerably vary because of the various internal external parameters. One is if you test it in Rajasthan, it will be something as tested in Mount Everest somewhere else. Okay. So, the operating ambient temperatures will be different. Okay. Similarly, another thing that happens is that as you go on loading it, the temperature will be could be high. For example, you know, we are doing some project on traction motors, and the temperature operating temperature traction motor is around 200 degrees centigrade. Okay. So, that is the problem. So, even small motors also it may get heated, therefore, your measurement parameters are sensitive to temperature, you must be very careful. Okay. Now, another thing is it will be desirable to measure the current, voltage and power simultaneously, right, not at different times as far as possible, because you know again the temperature and other things may vary even in these periods of things. Okay. Therefore, there would be errors due to power consumption in the meters are unavoidable. There will be power consumption in the meters, okay, and it itself will alter the actual status, okay, of these quantities. Okay. Therefore, what is we are telling a very rudimentary thing, I must have a very precision instruments. Okay. Then you must correct for errors due to power consumption in the instrument. Suppose you can't eliminate, you must have a mechanism to make some corrections in the readings due to errors of the measurements. Okay. Then choose a connection of meters which will lead to minimum power consumption, right, connect in such a way that there is a minimum consumption. Okay. And how do you know that your meters are accurate? Pardon? It's specified, okay, your meters must be say 0.1% accuracy, okay, 0.5% accuracy, okay. That is, but how do you know? It is written means, so many things are written, Pardon?
We have to get them calibrated.
How?
From standard institutes.
Standard institutes. So, what is, I think all of you should know one word which is done in instrumentation called traceability. Traceability. Okay. So, you should all be very clear about this term traceability. Where is your instrument traceable? However, our IIT Delhi instruments, are they traceable anywhere? Unless I must have my own calibration instrument now. So, one best thing is we should have one instrument in IIT which is a calibrated instrument, and it should be calibrated to some testing. There are standard testing labs, in the country. There are standing testing labs in the country which are recognized for calibration purposes, okay, and they are recognized also by international organizations, right? Because otherwise, a market, a product of our Indian industry cannot be sold, because they will start questioning, how do you know it gives you this much of quantity in terms of output. Therefore, these are all very important factors. And which is the ultimate lab in India where it has to be traceable? Which lab? Where are these instruments kept, which should be, in which I compare? Which is the lab? I mean, I can trace, I can trace to lab 1, lab 2, lab 3, See, the thing is IIT labs are traceable to lab 1, but that lab 1 must also be traceable to something else, okay. So, ultimately where it should be traceable? So, there are some labs, there are Central Power Research Institute, ERDA Baroda, they have calibration instrument, there are this STQC, testing quality control, I mean, done by the government organization. But there is one ultimate where it has to be traced. There is one lab in the country where it has to be tested. Which is that? Every instrument, if it has to have credibility, must be traceable to that lab. What is that lab? National Physical Laboratory, Delhi. So, it is there, all instruments have to be calibrated ultimately. Okay. This is the ultimate test lab in India. Okay. National Physical Laboratory. So, every lab in the country must be ultimately traceable to the NPL. So, you get, that means best thing is all your meters you better get it calibrated. Okay. Now, for example, okay, you can connect meters like this, is not it? So, you have an ammeter, okay, you apply a voltage and pass a current, this ammeter will measure a current, okay. Then you have the wattmeter here and the voltmeter here, okay, is not it? This is how you connect, right. Is there any error here? No error at all? Where is error? So, there will be a resistance drop here, and there is it will also draw a current here, voltmeter will draw a current here. So, this ammeter current is not the current going into the motor, right. What will the ammeter current do? Ammeter will current give you whatever is current going through this potential coil of the wattmeter, the current drawn by the voltmeter and this. So, in real practice, if you want to know the current of the motor must be equal to current measured minus, let us say I1 minus I2, is not it, right. Well, if you do that, that means, but the voltmeter, okay. So, obviously voltmeter you are okay, because that voltmeter connects the same voltage across the machine, right, and this. So, you can always say, so there could be error in the wattmeter, there could be error in the ammeter, there could be error to some extent in the voltmeter. Okay. So, there will be, this is one possibility. Okay. Then you can also connect you can connect like okay, you can connect like this, a wattmeter, voltmeter and ammeter. Is it okay? Is it better? No, but you are safe, this current is same as the motor current, is not it? Yeah, now the voltmeter will have a drop across this resistance of the ammeter. Ideally, ammeter must have 0 resistance, voltmeter must have infinite resistance, is not it? Therefore, why I am sensitizing you to these things is these are very important, because this current itself is small. See, in normal 5 HP motor which you do in a normal labs, then 3 HP, 4 HP motors, you know, the currents are maybe 5-10 amperes. If the current draws a few milliamperes, you can ignore it. But if this itself is a few milliamperes, okay. So, all these meters will load the testing system, okay. So, that is what you need to be. In fact, you will observe it more when you actually do a measurement in the lab, okay. So, voltmeter is connected directly across the machine to be tested, this is one way, and ammeter measures the current taken by the machine and the pressure coils, etc., is not it, okay. This is one of this thing. So, wattmeter will also measure the power consumed by the voltmeter also, right, is not it. You have connected a wattmeter, you know, before the voltmeter, right. So, it will consume not only the power consumed by the motor, but also by the voltmeter, right, you must be sure. So, power consumed by the voltmeter can be determined by removing the machine from the circuit and then appropriate corrections made. One option is first remove the machine and just check how much power the voltmeter is consuming, okay, for the same voltage. It is V square by R, where R is the resistance of voltmeter. Is it okay? In fact, I tend to be telling something which may be obvious, but why I am telling this is because this is important, okay. Now, for currents up to 1 amp, you know, of course, there are different types of meters, rectifier type, etc., okay, low power consumption. In fact, you know, the problem appears to be perennial, because one of the earliest books written by VNet, in 1935, there also it deals with the same problems, but I think now we are better off because our electronic instruments have come to our rescue, okay, which will have a minimum loading on the system. Okay. At that time there were no such thing were there, even transistors were not known at that time when this book was written. Okay. Therefore, I think now we can go in for better instruments, okay, and then we can get a better readings. Okay. Of course, then there were this VTVMs were there, okay, rectifier type electronic voltmeters were there, okay. And now the one of the thing which has come is the so called power analyzers. You are able to sense the voltages and current, you know, more accurately, and then you can also do a lot of calculations through softwares, okay. And that is one of the advantages that you can have. Then power measurement, for that you require a proper phase angle between the voltage and current, is not it? You need, because power factor of these motors are generally low. See, these small motors power factor will be say 0.2, 0.3, 0.4 power factor. So, obviously, there is a lot considerable errors if you have a problem in measuring the phase angle between the voltage and current. Okay. So, wattmeter should have different ranges for current and pressure coils. Okay. Okay, then for currents more than 0.5 amperes, you can think of different electrodynamic wattmeter may be used. Again, I think nowadays we have a better systems with power analyzers. For less than 0.5 amps, you can have precision wattmeter, low power factor have to be employed. Okay. Of course, sometimes there is a time where you can use the CR watt for phase measurements, because you can use the Lissajous figures to find the phase angle between the voltage and current. Okay. But I think nowadays perhaps you can do lot of soft computing. Okay. Then if you want to measure the winding resistances using DC voltages, voltmeter ammeter method or bridge methods, because resistance is very important of the windings which are low, and you can use for AC machines, you must use skin effect also. Okay. The skin effect, because you must, if you measure the resistance for different frequencies, you may get a different numbers, right. Then how do you measure torque? Because the torque may vary from very low value, say 10 to the minus 4 Newton meters or 6 Newton meters in a wide range of speeds, say 0 to 30,000 rpm. Small motor speed may vary from a low value, say a robo or a stepper motor may be low value, but it may go to very high value, okay, say 30,000 rpm or so. Okay. So, your speed range, torque and speed measurement, mechanical measurements are important. So, large errors arise due to torque measurement. This is one problem area. Okay. This occurs while measuring low torque at very low speeds. If you want to measure low torque at low speeds, there will be considerable errors that are possible. So, these are some of the constraints you have to care. Okay. Most stringent limitation on the time taken for measurements of heating of machine windings, because your torque measurements, after all, if there is a considerable heating, resistance goes up. So, torque readings may be affected, right, they will all be affected. Okay. Now, the generalized torque measuring device due to variety of machines and their applications, because you have, it is very difficult to have a ammeter voltmeter can be easily made, but torque measurement is always a big problem. Okay. Because what is the torque? Torque is the force to which the shaft is subjected to, and that will go on changing with the speed, changing with type of machines. Okay. Some will have a smooth torque, some will have torque pulsations. So, all these problems are encountered in the measurements. Okay. Then for good torque measurement, you require a low inertia, so that you decrease the time taken for measurements. You get low inertia system, you require a facility for measuring large range of torques at wide range of speeds. Okay. Then what are the features you expect for torque measurements? Are small magnitudes of errors, flexibility to test any type of machine, and reliability under all possible conditions of operations. These are some of the issues connected with torque measurements. Then there are torque ductors, torque measurement devices. There are strain gauges, that means you fix on the shaft. So, a strain that is experienced by this one, that is measured and that is processed. Okay. And there are what are dynamometers. Dynamometers measures the torque. Okay. Okay. Then a string or rope coiled around a light pulley with tubular spring balances, etc. In fact, one of the standard methods is, okay, you can have a pulley type of thing here, okay, right. So, it is running now, it is subjected to say some force F1 here through a spring balance and say F2 here, okay. You can adjust the torque, you can make a spring, you must have done it somewhere, I hope. Huh? Control lab you have done, you know how to measure the torque, okay. If this is the force and this is the radius, what is the torque equal to? F1 minus F2 and unit, what is the unit? When what is what? That is a Newton meter, okay. When F is in what unit? Supposing R is in meters, no problem. Huh? What will be this F1, F2? Can you measure? Do you have the spring balance? What do they actually measure there? Huh? Huh? Supposing this is in kg. Okay. Supposing F1, F2 are in kg, then what do you do? Huh? Into? So, torque will be F into R into 9.8 Newton meters, because 1 kg force is equal to 9.8 Newton force. Am I right? Though it looks ridiculous, all of you, many engineers forget about it, right. When once they get so much confused with kg meters, Newton meters and SP inertia, etc. See, because all these mechanical things you need to know. I think I am very glad the control system is at least one subject where you know about mechanical things, right. But if you know other subject, you know mechanical things, okay, right. So, anyway, I think you need to know and of course, there are other alternative ways also, like you make a prony brake, where you have a, it puts a brake and this is a W at a distance R, okay. This is one way of means, so it puts the brake on this thing, it is called a prony brake, okay, like a brake on a bicycle you can say, okay. So, the torque will be equal to W into R, okay, where W is, this should be in newtons, Newton force, okay. And also you have of course, other thing you are supposed to have shown DC dynamometers. See, you connect a DC machine, supposing you have this is the test machine, this is the DC machine, okay, and then you have a swinging frame, right. So, this is a swinging frame, swinging frame dynamometers. So, as soon as you load it, it swings, right. So, you will notice that a swinging frame means you connect some meter here. So, it swings, right, and there is again a distance here, and let us say this is F here. So, torque here will be again equal to F into R. It is called a swinging frame. I mean, you have a good spring spring balance, okay. So, this is a spring balance here. This is one way, okay, and there are also there are eddy current dynamometers. So, there are typically for medium ranges, and there are hysteresis dynamometers. See, what is a dynamometer? Dynamometer is one thing where it has to dissipate the heat. It is artificial loading of the motor, right. When once you apply a torque, see, even when you apply a brake on your bicycle, it generates heat, isn't it? Any brake means generates heat, because what is a brake? Is basically of destroying of kinetic energy, right. When once the kinetic energy is dissipated, there is a power. Okay. Therefore, eddy current, that heat is due to eddy current flowing in a you make a disc. So, after all for a shaft you connect a disc, okay, and have a magnet or something like that. So, it will induce a eddy current in them. So, that it becomes a loss, it will generate a negative torque or loads the motor. Okay. Similarly, you can even have a hysteresis, magnetic hysteresis also is a mechanism of hysteresis loss. Okay. So, obviously, all the mechanism of braking or the loading, mechanical loading is a method of dissipating the power. Okay. Now, all this there are several ways are there. I would suggest that you look at the testing systems available in different laboratories and understand. Okay. Now, next is measurement of speed. How do you measure the speed, right? Again, if you put a tachometer, the small motor such that they may stop also. Really, you try, if there is a small motor, that means if you just put a tachometer, okay, and it will just motor will stop, okay, your tachometer itself will work like a load, is not it? Okay. So, because the power itself is small, therefore, you must be, in fact, we would prefer to have a non-contact type. Okay. I am sure that nowadays I have been suggesting that you should create a non-contact type where you have a encoder or something, where you just measure the pulses it will generate and process the pulses to get the reading, okay, digitally. Therefore, ordinary tachometers are difficult, are not suitable, okay. They cause loading. Now, one way is stroboscope or digital tachometer. You heard of stroboscope? Anybody not heard of a stroboscope? You have not heard of stroboscope, okay. All of you have gone to cinema halls? I think anybody not gone to a cinema hall? Okay, you have seen the fans rotating in the cinema hall, if they are not, have you observed the fans? You have observed, no?
They are saying
No, you have not seen, you have gone to AC only. There are some cinema halls, there are fans,
yes, sir.
ceiling fans are rotating.
Yes, even they can observe in our room. We can observe in our room also.
No, you are observing in your room, ceiling fan rotating, you observe in your room, but anything else you observed. Anything else you have observed?
Yes, sir. Yes, sir.
Strobo effect?
Yeah, sir. That sometimes when light frequencies.
So you get a feeling it is rotating slowly in the opposite direction, isn't it? So the thing is that the frequency of the light which is impinging on the screen, that one, and it's and you have a feeling that your ceiling fan is rotating in a slow motion. That is the strobo effect. Okay. Therefore, if you have a, so that is I suggest that we have stroboscope in our labs, you better use it. So, if you have this stroboscope, it just flickers, okay. This is the stroboscope, and here is your machine rotating. One way is you can make it stationary. So, that means you can adjust the frequency in such a way they are stationary, that means whatever is the reading of the stroboscope will also give you the reading of the speed. So, this is the stroboscopic method, right. In fact, you can also measure speed, and also you can, one of the advantage you can measure slip also. Slip means you supposing this is rotating at a speed n and this you flicker at a frequency f which is proportional to ns. So, it will go on counting, rotate in opposite direction. So, you count how many for 1 minute, how many times it has rotated, right. So, you will have a slip speed you can measure, is not it, by manual measurement. Is it clear? So, your rotor is rotating, you just keep a disc, attach a disc to your motor end shaft, and go and then make some marks over it. So, it has some radial marks and project this strobo light, and when this is flickering at synchronous speed, okay, if the machine is also at synchronous speed, it will be stationary. Okay. Now, if it is rotating less than synchronous speed, it will rotate in the opposite direction at slip speed. So, if you know that it is rotating at 10 rpm, means slip is 10 rpm. Okay. If it is synchronous speed is 1500, so it is slip is 10, means actual speed is 1400. Therefore, because slip is again another funny thing, difficult to, it may make errors, right, because this is one, if you want to actually measure the slip, there will be a error in slip measurement, because it is the difference between two big numbers, okay. And even if there is one error, means instead of slip equal to 10 rpm, if you measure 8 rpm, it is a 20% error, right. Therefore, you must be careful in measurement of slip. Okay. Right. So, as you say, for induction machines, slip speed is within about 100 rpm, then slip meters are used. There are what are slip meters. Actually, this has become a very critical thing, because many testing done on submersible motors, etc. They have slip coils. Sometimes they put some slip coils, so that the signal is proportional to slip frequency. Therefore, these are all important measurements. Okay. Now, these are some photograph of the latest test instruments that are used, okay, for different quantities. As you said, these are the clip on meters. You clip, that means you put it over the wires, it is a tongue testers type of thing, and what it does is, it is actually a current transformer, and it is broken, the core is broken, and when once you clip it in, a core becomes a closed path. So, it is a that means the signal, whatever current flowing to the winding gets transferred to the instrument. Okay. And so, these are all the different type of meters which we procured, which are fairly recent, and one can look at this. Okay. These are also another testing instruments, okay, for measurement of various quantities, because if you want to several quantities electrical mechanical, you may like to measure for, if you are to test a fan, you may also like to have the winds, speed of the air that blows, right. Anemometers are required, you want thermometers. Sometimes if you want to measure the pump, you need the flow meters, right. So, you need to measure speed, linear speed, rotational speed, temperature, you need frequency, mechanical side. So, there are several of the quantities which you need to measure if you to be accurate. What you want to measure? What are you interested to measure? Voltage, current, power, harmonics, THD, okay. Electrical, what are the things, only these, okay, power factor, VAR, they may be derived quantities, okay. You need all these things to be measured, okay. Then you may require, mechanical things, non-electrical, you may require temperature, torque, speed, force, flow, air velocity, okay, slip, right, linear velocity, displacement. Supposing you are working on some robots, etc., linear displacements. So, there are several such non-electrical quantities to be measured, because it is the electromechanical system basically. So, there should be a proper way of measuring this. and all these are become nowadays. Why all these have become important is nowadays a new term has come, you have to measure the energy, okay, energy audit, right. So, tomorrow you can go to a shop and say first, instead of telling what is the cost of this equipment, you should ask how much power it will consume, right. But he will give a cheap equipment, it will consume double the power, is not it. So, nowadays that is the reason why air conditioner are coming with the low power consumption, right. So, you need to be very clear about it. Okay. So, these are all again there are power analyzers. Power analyzer will actually I hope many of you must have used it, right, but it is yet getting into laboratories in most of the institutions. Therefore, these are all the power analyzers, okay, which are in our labs, and you can use them. Okay, these are all similar. These are the power analyzers actually. Okay, these instruments, they are single phase. This is 3 phase, single phase, 3 phase power analyzers. So, they can be quite useful from this point of view. Okay. And I have just show you this. I think since you say you have used it, let us see whether you can get the feel of this. Okay. Right. I mean, just a matter of you know how to, there is a, okay, typically this is one of the standard meters, okay, made by Fluke, power quality analyzer they call. So, you can measure voltage, current and frequency as indicated in this, right. So, then you can measure power. If you wrote this, it will measure power, this. Then of course, then you can measure the harmonics, okay, and of course there are other quantities like sag and swells, transients, then inrush current, then you can have the okay, just one second. So, yeah, okay, it's apparently battery is low. I think since you said you have used it, this is what is being done. Now, most important thing is okay, I think what you have used this anyway, that this is how you if you want to measure a current through this wire or something, so you connect like this, isn't it. Now, this is a current transformer. Why I am just deliberately telling is you must have used it, but not knowing what it is actually, right. So, you will observe that this is actually a core, what you see, this is the core, and this when you pass some wire. So, whatever is the current here, it gets reduced, and the reduced current will go into the meter, right. So, it will measure actually the current with this thing. What is the advantage of this thing? You can do measurement without actually disturbing the circuit. You do not have to disturb the circuit, but in any other place you have to go and disconnecting the circuit and measure the current. Okay. So, nowadays it has become very handy everywhere, every mechanic will use it, and so this instrument as you have indicated here, it will measure voltage, current, frequency, harmonics, power and everything, and it is very handy. Anybody can go to any place and ensure that how much power it consumes. And I think if you one of the assignment I can give is you just measure the power consumed by different gadget in your house. They are all motors anyway. See how a fan, okay, okay, will you do that? Yes. Yeah? Huh? Okay, because Because people will always grumble that they have got too much of power consumption, when they get the electricity bill at the end of the month. But that is because there are several gadgets in the house, we see, you think they are very innocent, but they are not innocent, because many of the gadgets are consuming enough power, your refrigerators, your food mixers, all of them, your computers is nowadays, I think it will, and even your UPS. See, UPS, when power electricity goes, it goes on, silently charging your batteries, it will take 200 watts or so, that consumes. So, more power it goes, more power for the charging. Similarly, you do not bother to switch off your UPS, etc. Okay, and in standby mode also it goes on, consuming power, right. So, you take a printout of your laser printer, it will consume power, a scanner consume power. Okay, you just check how much, because everything is becoming important, because after some time, there will be a lot of ration on the electricity consumption. Therefore, you must know. So, I think this is one assignment, you find out how much power different gadgets will consume. Okay. Okay, we will close it here. Actually, I wanted to finish, I think we will have to discuss the actual testing of single phase motors in the next class. Okay.